In this video, we'll compare the ChatGPT user interface to the OpenAI Playground. Using Postman, we'll call the Playground API so we can understand how to develop an app. In the next step, we'll create a Spring Boot app using Spring Starters, import our solution into IntelliJ Community Edition, and code a solution to make Playground calls from our application. As we go along, we'll learn some best practices, like how to externalize the API key we'll be using, and much, much more. We're only using freely available tools and APIs, so this video will work for anyone. Let's get started. By now, most of us are familiar with the ChatGPT user interface. We ask questions and get back responses through the ChatGPT website. If we ask a question like, "What's a good name for a dog groomer?" we get back a list of possible names that meet our criteria and might be something we'd want to consider for a business name. But there's another site called Playground where you can experiment with the OpenAI API. The URL for this site is platform.openai.com/playground. To use the Playground, you'll need to sign up for a free account to get started. After a while, or a transaction limit, your account won't work anymore, so you'll need to pay for it to continue using it. Here in the Playground, we see a text box entry where we can enter the same question. What's a good name for a dog groomer? Click Submit and get back a single response. The Playground is more geared toward giving a concise and focused response, so we only get back one answer. Up in the top right corner, we see the button View Code. If we click on that, we can see the command we sent to the Playground, written as a curl command. Let's copy the code by clicking the copy link, close out of that, and open up Postman. If it's new to you, Postman is a software tool used for testing, documenting, and interacting with web APIs. Let me know in the comments if you'd like to see some videos on Postman. In Postman, let's click on the Import button, and in the text entry field, paste in the curl command we just copied. Postman parses the command and loads it up as a post request. If we click on Headers, we see that we need to supply a bearer token to make a call to the API. And if we click on Body, we see the format of the request JSON object that we need to send. Notice what we copied has both the question as well as the answer we got back. Let's clear out the answer so we can ask the question again. And let's try submitting the request by clicking the Send button. Not surprisingly, we get an error message. It says our request is invalid because we didn't supply a valid API key. Let's go back to Playground and click on API Reference in the menu. We don't care about saving our dog groomer question, so let's go ahead and click OK and continue. Under the Authentication section, we see a link to the API Keys page. Let's click on that, and we're presented with a page where we can generate API keys for our testing. Let's click the button, Create New Secret Key. We're asked to give it a name. Call it whatever you like. I'll call mine My Key, and click the Create Secret Key button. This is the only time we're able to capture the secret key, so let's click the Copy button to save it in the buffer. And then click the Done button to close the dialog box. By the way, I've already revoked all my keys, so should one not be blurred out during the video, don't worry, it won't be usable any longer. Let's go back to Postman. Rather than copy the value into our request, which isn't secure, let's click on Globals and add a new variable. We'll call it Open API Key and set the type to secret so it's not shown on the screen. And then copy it into the initial and current values. Then click Save to persist the change. Let's go back to our post call. We'll close out all of the response information from the last call. Then click on Headers. And where the variable $OpenAPI Key is, let's get rid of that and add double curly braces, which indicates that we're entering a variable name. Then we'll add OpenAPI Key, and then click Send. Notice in our response, now instead of an error, we get a suggestion for our dog grooming salon, Pet Pampering Palace. And if we click Send again, we get a new name, Positive Pet Pampering. Awesome, so at this point, we know how to get a key, create a request, and view the response. Looking back at the request body again, we see the JSON object used to make our call. Now let's create some Spring Boot code to do the same thing. We'll begin by going to start.spring.io, and we'll use Spring Initializer to generate our startup app. If you're using a tool like IntelliJ IDEA Ultimate, you can do this step from within your application. But I want to use only free tools in this video, so I'll generate the project here and then import it into the Community Edition of IntelliJ. We'll just make a few changes to this page. Let's use Maven to build our project. And for our group, we'll make it com.beginsecure. And we'll give our artifact a name of OpenAI App. Everything else in this column looks good. For dependencies, let's add the web dependency so we can construct and call REST endpoints. Now let's click Generate to create our starter project code. Let's open the Downloads directory, and then right-click and select Extract All. That opens a new File Explorer window. Let's pull that one over. And in our first window, let's drill into the projects folder on my machine where I keep my code. And I'll simply drag the new folder for the new project into the projects directory. Let's drill into it to make sure it looks good. Yep, there's the POM and the directories I would expect to see, so we're all good. Now let's open IntelliJ IDEA Community Edition. This is the free version of IntelliJ and doesn't allow us to generate the Spring Boot starter code like the Ultimate Edition does. Since the code exists, we'll click Open, and then we'll go select the project folder under C, and then the OpenAI App directory, and click OK. We'll select Trust Project since we know the code is safe. Let's go ahead and click the Load Maven project. We'll close all notifications. If we look at the POM file, we can see it's a very basic Spring Boot application. The only non-default dependency is the web starter. All right, let's start building our app. First, let's open the application.properties file. We'll externalize a few properties rather than hard coding them. I've added a screenshot from the work we did in the playground so we know what to do here. First, we'll add a property called OpenAI.API.model. Referring to the screenshot, we can see it should be set to test-davinci-003. And we'll add a second property called OpenAI.API.URL. Again, referring to the screenshot, we'll set it to https://api.openai.com/v1/completions. Now let's create the code that we'll use to make our REST call. First, we'll create a package called client. Our class will be called REST Client Config. Let's go ahead and add the @configuration annotation to the class now so that we don't forget. This means our class will contain bean definitions annotated with @bean. These methods define and instantiate beans that are managed by the Spring container, and we'll use them elsewhere in the code. Let's add a class-level variable called OpenAPI that will manage our secret API key. We'll annotate it with the @value annotation. This annotation lets us inject data from properties files and even environment variables. We'll give it a value of OpenAPI.key. If you recall, this was not a property that we included in our application.properties file. We never want to add keys, tokens, passwords, or other cryptographic material to a properties file. Instead, we want to inject it into our application. We'll be getting this value from the environment when the app runs. We'll see how to do that later in this video. Next, let's create a method called template that returns a REST template. The REST template class is a synchronous HTTP client that makes writing code that calls RESTful APIs simple. We'll annotate it with an @bean so the Spring container will manage it for us and allow us to auto-wire it later in the code. We'll start by creating a REST template object of type REST template. We'll call the getInterceptors method, which retrieves a list of the interceptors registered with the REST template. This gives us access to the list of interceptors that will be applied to outgoing requests. The add method adds a new interceptor to the list. It's defined as a Lambda expression that takes 3 parameters: the request body, and the execution object. Next, we'll add an authorization header to the request headers. The value will be the word bearer, followed by the OpenAPI key. Make sure you put a space after the word bear. There, I just saved you 30 minutes of Googling or searching on Stack Overflow. The execute method passes the modified request and request body. This allows execution of the subsequent interceptors and the final execution of the request. Finally, we return the REST template after it's been modified. Now let's work on the request and response classes. First, we'll create a new package called DTO, which stands for Data Transfer Object. And let's create a class called ChatGPT Request to hold our request data. This will be a POJO or plain old Java object with no Spring annotations. Let's model it after the JSON object that was used for the body of the request we made in the playground. We'll add class-level variables for each item from the object. Model and prompt will be strings, and everything else will be an integer. We'll initialize all the integers to the values they were in the object and leave the strings unassigned. Now let's generate some code. We'll create a no-argument constructor, and we'll create a constructor just for the model and prompt, so we can supply them when we need to make a call. Then we'll add getters and setters for each of the class variables, so we can tweak them as needed. And finally, we'll add a toString method in case we're going to print out the current state of the instance of the class. Next, we'll create a class called choice. We'll be modeling this after the response we got back in the playground. We only care about the text and the index, so we'll create class-level variables for those fields and ignore the rest. We'll add a no-argument constructor, two-argument constructor, getters and setters for both fields. We'll add a toString method, and for good measure, we'll add an equals and hashcode method. Implementing equals and hashcode methods in a Java class is important when comparing objects for equality. Some of the code under the covers might be making use of this, so better to be safe than sorry. Finally, we'll create a class called ChatGPT Response. It's also a POJO. It's simply a wrapper for the list of choices. Looking back at our response, we'll see that choices is an array of objects, which is what this class will model. We'll add a one-argument constructor for the list. We should probably add a no-argument constructor as well, so let's do that. Then we'll add a getter and setter for the choices field. And finally, a toString method. All right, we're almost done with the coding, just one more class. Let's add another package called controller. And we'll create our controller and call it OpenAI API Controller. In Spring Boot, a controller class is responsible for handling incoming HTTP requests and returning appropriate responses. It will receive the message we send, use the REST template bean we created, and call the OpenAI Playground. Get the response, and then write out the result for our application to use. We'll annotate our class with an @REST controller annotation. First, let's create 3 class-level fields: model of type string, URL of type string, and template of type REST template. We use the value annotation to assign model the value of the model we configured in our application.properties file earlier. Similarly, URL will be assigned a property from the application.properties file. For template, we use the @AutoWired annotation. This will ask Spring to search the application context for a bean of this type and assign it here. This is called dependency resolution. Recall in our configuration class, we created such a bean, so we're all good here. Next, let's create a method called chat that returns a string. The @requestParam string prompt indicates that the prompt query parameter is expected in the request URL, and its value will be assigned to the prompt variable. The @getMapping is a Spring annotation that maps this method to handle HTTP GET requests to the chat endpoint. Next, we'll create an object called ChatGPT Request of type ChatGPT Request. We'll use our 2-argument constructor to create an instance using the model we've configured and the value of the prompt passed to this method via the request. The call to template post for object performs a post request to the URL endpoint, sending the ChatGPT request object as the request payload. The response is automatically mapped to an instance of the ChatGPT response class and is assigned to our ChatGPT response object. This code retrieves the response content by accessing the choices list within the ChatGPT response, selecting the first choice, and retrieving the text of the associated message. Keep in mind this is not production-grade code. There needs to be a lot of error handling here to make sure that everything is robust, but it will get you an MVP working very quickly. Let's go back and look at our REST client config class and deal with the API key now. As we discussed earlier, we don't want to store the API key in the source code or configuration file for the application. Instead, we want to externalize the key and inject it at runtime, whether in production or during development and testing. Let's go back to the API keys page on the Playground and create a new key. We'll call it anything, it really doesn't matter. Let's make a copy of the key. And now in Windows, let's search for Edit Environment Variables. This will allow us to add custom environment variables. You should be able to add variables for your user account. So let's click New under the top list of variables. For our variable, we'll paste in the key we just copied. And for the variable name, we want to carefully match the name of the string in the @value annotation. It should be in all uppercase, and we need to substitute an underscore for a period in the name. This is a cool trick that Spring provides us for reading from the environment. Let's click OK, and then OK once again. Next, we'll need to restart IntelliJ, so we'll pick up our environment variable edits. To do that, we'll go to File, and then scroll down and select Exit to terminate the IntelliJ IDE. Once it shuts down, we'll restart our IDE, and this should take us back to the project we were just working on. Once the application is fully loaded and indexed, we see a green arrow that we can click on to start our application. Our application startup is clean, and there are no errors in the log file, so let's go ahead and open a browser. The URL is already in my cache, but we'll type in localhost :8080/chat ? And then the prompt that we've been using, what's the good name for a dog groomer, followed by a question mark, and press enter. And we get back a message that says positively groomed. If we refresh the page, it will submit a new request, and we get back another response. This time the suggested name is Perfect Pet Groomers. Going back to our IDE, we see that we have no error messages and everything is working fine. So go forth and create something awesome with it. If you enjoyed this video, please like and subscribe. Thanks for watching, and remember to always begin secure.